This is a continuation of the Chapter 10 review with problem 46. In this problem, we're given a point, and it says the point is on the circle with center -7, 6. Write the standard equation of the circle. Now, I like to have pictures, so I'm going to draw a grid in here, and I'm going to try and just sketch this out real quick. So it's at -7, 1 is our point. So 1, 2, 3, 4, 5, 6, 7, and 1. So there's our point, and the center is at -7, 6. So 2, 3, 4, 5, 6. So there is our center point. So we have a circle going around like this. This is obviously going to be my radius. So if this is a rough image of my circle, really ugly circle, but this is my radius. What I need to do is I need to have the distance from here to here. And that point is -7, 1. So from here to here, that's the distance formula. So -7, 6 and -7, 1. So -7 minus a -7 gives me 0. 6 minus 1 is 5. So square, add square root. So this is 0 square root of 25, which is 5. I could have just subtracted the two values, but I just wanted to show you the distance formula one more time. And so our radius is 5, and we can find our equation by saying x minus h squared plus y minus k squared equals r squared. We have x minus, our center is at -7 squared, plus y minus k is 6 squared equals r, which is 5 squared. That gives us x plus 7 squared plus y minus 6 squared equals 25. And that's our equation. Now we'll move on to problem 47. In problem 47, we have this really strange looking form of an equation, but we can see that we have an x squared and a y squared term. We have an x and a y as well in here. And this form is known as the general form of the equation of a circle. It's fairly clear that it would be very difficult to figure out the center and radius using this form. So we're going to need to convert this general form into the standard form of the equation of a circle. And the way we do that is to combine our x terms and our y terms, and we're going to create two separate quadratics, and we're going to use the completion of the square idea to give us our standard form. So if you remember completing the square from your algebra class, this is where it's going to come in. To start off the process, I'm going to go ahead and group my x terms and my y terms together. That gives me x squared minus 12x, and then we have plus y squared plus 8y, and I'm going to put the constant on the other side of the equal sign, equals -48, just to get that out of the way. Now, I'm going to take these two terms, and I'm going to complete the square on these two terms to create a quadratic equation. What that gives me is x squared minus 12x, and I put these in parentheses, and I give myself a little space here. Now, to generate a perfect square trinomial, which is what I'm looking for, this term has to be a square, this term has to be a square, and this term has to be the square root of this times the square root of this times 2. So to get this term, I take this term and divide it by 2. So negative 12 divided by 2 is negative 6, and we square it. So that gives me a plus 36. Now, because I have a plus 36 here, because I've added 36 to this side of the equal sign, I'm going to have to add 36 to that side. So we're going to add 36 out here in a second. But we have to remember we have to add our 36 in. Now I'm going to do the same thing to these two terms. I'm going to complete the square on these two y terms. So this is plus, and we have y squared plus 8y, and give ourselves a little space, equals, and then we have this negative 48, and remember we had this plus 36 out here. So plus 36. Now, just like we did over here, we have to create a perfect square trinomial. So this is a perfect square. I need a perfect square over here, so I take this term, divide it by 2, which is 4, and square it. That gives me a 16. So since I added 16 to this side of the equal sign, I have to add 16 to this side. Now, I have a perfect square trinomial. This perfect square trinomial is the equivalent of the following. We take the first term and square root it. We take this sign and this term and square root it. And square the whole thing. So if we were to take the square of x minus 6, in other words, if we multiplied x minus 6 by x minus 6, we would get this term. Do the same thing here. Plus square root of this, y, this sign, and the square root of that, 4 squared. Now we combine these values over on this side. And negative 48 plus 36 plus 16 gives us 4. So that tells us that based on this, we know our center is at 6. It's always opposite the sign here. Negative 4. And our radius, since this 4 equals r squared, take the square root of both sides, our radius equals 2. And that's how you perform this conversion. Completing the square twice, creating our binomial squared, which gives us our center point, which is always opposite sign. So positive 6, negative 4, and the square root of this value is our radius. And let's move on to problem 48. This problem is asking us to prove or disprove that the point 4, negative 3 lies on the circle centered at the origin 0, 0 and contains the point negative 5, 0. What this is really asking us to do is to find the equation of the circle centered at the origin with this point on it and show that this point satisfies that equation. So we will find the equation of the circle, substitute in this for our x and this for our y, and see if the equation works. What that requires is just what we've been doing. Find the equation of the circle centered at 0, 0 with this as a point on the circle. We need to find out how far this point is from the center. Well, since we have the circle centered at the origin and this point is at negative 5, 0, way out here, we know that the radius of the circle has to be 5 because the circle's doing this. And so since the radius is 5, we should be able to find our equation fairly easily. Since our h and k are both 0, we have x squared plus y squared equals 5 squared, which gives us x squared plus y squared equals 25. Now, to determine if this point is on this circle, we simply substitute this value for x, this value for y, and see if it equals 25. So we have 4 squared plus negative 3 squared equals 25. 4 squared is 16. Negative 3 squared is 9 equals 25. 16 plus 9 is 25. 25 equals 25. So yes, this is true. This point is on the circle, and we've just proven it. Now, while we're in the mode of proving things, just as an aside to this problem, you may see problems from time to time that say, prove or disprove that a particular point is either outside, on, or inside the circle. Now, those problems may sound kind of strange and difficult, but they're really pretty easy. That's all you really have to do. Given any particular point, you would find the distance from that point to the center of your circle and determine if that distance is greater than, equal to, or less than the radius of your circle. Obviously, if the distance from some point, let's say we had a point sitting out here, if the distance from this point to that center is greater than the radius, that point is outside the circle. If the distance from the point to the center is equal to the radius, that point is on the center. And if the distance from your point to the center is less than your radius, then that point is inside your circle. So just a little aside, a little bit of extra information to help you, because there wasn't a problem like that in this review, so I wanted to add that in. That wraps up the Chapter 10 review. I hope it was helpful to you, and perhaps I will talk to you in another video.